Chapter 5, Discounted Cash Flow Valuation. Okay, in this chapter, what we're going to do is we're going to extend what we did in Chapter 4. In Chapter 4, all of the future value and present value calculations we did were with one cash flow, either one cash flow going out or one cash flow coming in. Well, in the real world, that doesn't happen very often. It happens, but not as frequently as multiple cash flows. So in this chapter, we're going to extend what we did and include multiple cash flows. We're going to by doing that, we'll be able to calculate loan payments and find an interest rate on a loan. We're going to talk about how loans are amortized or paid off. And we're going to talk about how interest rates are quoted and misquoted. All right, the outline. First, we're going to just go through how do you calculate future and present value multiple cash flows. And then we're going to talk about annuities and perpetuities. And then we're going to look at the different interest rates, the effective annual rate, and the APR, the annual percentage rate. And then we're going to talk about loan types and loan amortization. Okay, and we're going to go through and use all three methods. There's a couple problems where the alternative methods are in the last few slides of the presentation, but I'm pretty sure that all of the problems have all three methods used. Okay, so let's start about future cash flow. Remember, in a future cash flow, we're going to get the cash at the end of the periods of time that we're looking at. So here, we think we'll be able to deposit $4,000 at the end of each of the next 3 years in a bank account at 8% interest. Currently, you have $7,000 in the account. How much will you have in 3 years? Okay, so let's try and picture what's going on here. At the end of the first year, we're going to put $4,000 in. At the end of the second year, we're going to get $4,000 in. At the end of the third year, you're going to put $4,000 in. And what they're asking you is after that, at the end of the third year, when you put that $4,000 in, how much will you have in the account? Okay, and you currently have $7,000 in the account. All right, so we're going to, if we think about that, the last $4,000 will earn no interest because it's put in at the end of the period, and that's when we're doing this calculation. So it can't earn any interest if it's just put in there. The amount that's put at the end of year the end of year one, will earn 2 years worth of interest. Year 2, interest for year 2, interest for year 3. The amount that was put in at the end of year 2 will earn interest for year 3. Okay, so they're asking two questions. How much will you have in 3 years? How much will you have in 4 years? All right, so in 3 years, we're going to remember, this is a future value problem. We know today that it's what it's worth today, and we want to find out, when we know the cash flows that are going to go in, we want to find out the value in the future. Okay, so year 0, which is today, we have $7,000 in the account. You can say, it says here, you currently have $7,000 in the account. So that $7,000 would earn interest in year 1, 2, and 3. Okay, so we're going to take $7,000 times 1.08, 8% interest to the third power. And that should give you $8,817.98. In year 1, you're going to put $4,000 in. And as I said before, that's going to earn interest for 2 years because we're putting it in at the end of year 1, so it'll earn interest in year 1 and interest in year 2, or I'm sorry, interest in year 2 and interest in year 3. And then, so that's 4,000 times 1.08 to the second power, and that's 4,665.60. In year 2, we're going to put another 4,000 in, and that will earn interest just in year 3. So it's to the first power. So that's 4,000 times 1.08 to the first power, and that's equal to 4,320. In year 3, we're putting 4,000 in at the end of the year. It won't earn any interest because we put it in at the end of the year, not at the beginning. Total value in 3 years, we add those 4 up, 21,803.58. Okay, so then the next question becomes, if we go back to the slide, it says, how much would you have in 4 years? All right, so if we have 21,803.58 in 3 years, in 4 years, we would earn 8% on that, and that would give us the value at the end of 4 years. So we're going to take that 21,803.58 times 1.08, and that gives you 23,547.87. Okay, and if you want to see the calculator and Excel solutions, you can click on those. It'll take you to the back of the presentation, and you can go through those. You know what? I'm going to take us back there, especially for the calculator solution. Okay, what we're going to do is, what you're going to have to do is enter all of these amounts separately. So the year is going to be 0, so n is 3 because it's a 3-year time period. The interest rate is 8. The present value is minus 7,000, and then we're going to, the payment is 0 because there's no payments here. We're putting a different amount every year, so we're showing them as the present value. And we're going to compute the future value, and then you're going to hit that compute future value. It's 8,817.98. In year 1, we're going to have the payment made at the end of year 1 will earn interest for 2 years at 8%, $4,000, and that'll give us 4,665.60. In year 2, we're going to put another payment of 4,000 that'll earn interest in year 3 at 8%. 4,000 is 4,320, and in year 3, we're going to have the 4,000 that we deposit at the end, which will give us the 21,803.58. The value at the end of year 4, we're going to take this, n is 1, interest rate is 8, the present value is 21,803.58, and that's really the present value at the end of year 3. But we can do that because we've already calculated what the values are worth for you at the end of years 1, 2, and 3. And we're going to compute the future value, and that'll give us 23,547.87. Okay, let's do a second example for future value with multiple cash flows. In this particular example, you're going to deposit $100 at the end of 1 year, $200 at the end of 2 years, and $300 at the end of 3 years, for a total of $600. How much will you have in 3 years at 7% interest? Okay, so 1 year using the calculator, year 1, the cash flow, you're going to hit the CF button, 2 for N, minus 100 for the present value, and it's important that you put that minus sign in there. 7 for the interest rate, the I slant Y, and you're computing the future value because they're asking you how much interest will you have in 3 years in the future. And that should give you $114.49. Year 2, the cash flows are a CF on the calculator. 1 is N, minus 200 is the present value, 7 is the I slant Y, And then again, you're going to compute the future value. That's going to give you $214 and even. Then you want in year 3, you want a discounted cash flow. So you're going to use the cash flow calculation, 0 for n. Why 0? Well, the money is deposited at the end of 3 years. So at the end of 3 years is at the same time, how much will you have in 3 years? So it's basically going to be the $300. There's not going to be any discounting on that one because of the fact they're both occurring at the same time. When this deposit is being made and how much interest and what interest they're going to earn. They're not going to earn any interest at the end of 3 years because you're just making that deposit at the end of 3 years. So if we add those all together, it's $628.49. Okay, so that's what we have at the end of 3 years. And then it says how much in 5 years if you don't add additional amounts. Okay, well, we'll take that, what we had at the end of 3 years, $628.49, and we're going to multiply it by 1.07. The interest rate is 7% squared, because when we're using squared, because we're going from 3 to 5 years, so that's 2 additional years. If we went from 3 to 6 years, it would be cubed, 1.07 to the third power. Okay, so if we multiply this out, it comes out to $719.56. Okay, notice in both cases, the amount, the future value is greater than what we put in. Try and get in the habit of kind of double checking your work for reasonableness. It's a really good skill to develop, not only here for your work here at Hiram, but also when you get out in the world. The last thing you want to have happen is you do something and the numbers they're wrong, and they're so wrong that it's embarrassing. So always get in the habit of checking your work. Both of these amounts are greater than the $600, and that makes sense because we deposit and we're earning interest, so we not only have what we deposited, the $600, we should also have interest incurred on those deposits. The next slide is just a timeline showing when all the deposits made and how it came to that $719.56. Okay, here's another example. The future cash flows. In this particular example, this is the same example, but it is using Excel as a calculator rather than as a calculator. You're going to use the future value function, and in the future value function, first thing is your interest rate, so that's 0.07. The next is the number of years worth of interest that you're getting. In year 1, if you deposit the money at the end of year 1, you're going to get interest in year 2 and year 3. So that's 2 years. If you deposit the money at the end of year 2, you're going to get 1 year's worth of interest. If you deposit the money in year 3, you're not going to get any interest at the end of year 3. The next value, it should be present value, but since we're using, the next one, I'm trying to remember what it is. But 0, and then we're going to put minus and then the present value. Okay, and it should come up with very close to the same numbers. They might be slightly different by pennies, but they should be very, very close. Okay, and just something on an exam, I'm not going to get crazy over pennies. If you came in and you typed it out and you rounded slightly differently and you came in at 628.48, as long as all the math was correct and you did use, everything you're supposed to have done, full credit, no problem. Okay, future value, multiple cash flows. Here's another example. Suppose you invest $500 in a mutual fund today and $600 in 1 year. If the fund pays 9% annually, how much will you have in 2 years? Okay, so if we invest $500 today, that means it would earn interest for 2 years because we put the money in at the beginning of year one rather than at the end of year one. And so we would take 500 times 1.09 to the second power, giving you 594.05. And then the $600 we're depositing at the beginning of year two. So it'll earn 1 year's worth of interest, the second year. So that's 600 times 1.09, giving you 654 for a total of 1248.05. Okay, how much would you have if you make no further deposits? Well, there's a couple different ways to solve this. I will not require you to do it in one way or the other. You can select the method that you want to use to solve these problems. And I will not, as long as the method you used was used correctly and you came up with the correct answer, you will get full credit for it. Okay, so the first way, basically we're going to redo what we did back here, okay? Only we're going to adjust it for the number of years. So if there are 5 years, the $500 will earn 5 years worth of interest, and the $600 will earn 4 years worth of interest. So we would have 1616.26. Okay, so again, just as a double check, look at you deposited 500 and 600, and that's going to give you $1,100. At the end of 5 years, you're going to have $1,616.26. It's more, that makes sense because you've earned interest. The second way, we're going to use the value at the end of 2 years. We're going to go back here, use this value, and then we're going to multiply it by 1.09 to the third power. We had 2 years. We want to have interest at 3 years or 5 years, so we need to add another 3 years to that, and that will also give us the 1616.26. And if you want to go and you can look at the calculator and the Excel solutions. Example number 3. Suppose you plan to deposit $100 in an account in 1 year and $300 into the account in 3 years. How much will be in the account in 5 years if the interest rate is 8%? Okay, so we're going to deposit $100 into an account in 1 year. So we're going to take that $100, we're going to multiply it by the interest rate, the 1.08, and we're going to take it to the fourth power because we deposited at the end of 1 year. So it's not going to earn interest that first year. And if we look at 5 years out, so we take 5 total years minus 1 year of which the interest isn't going to be earned, so that's 4, plus 300 times 1.08 squared. All right, we're going to put 300 in the account in 3 years. So that means for the first 3 years, there's not going to be any interest earned on that one. So 5 years minus 3 years with no interest earned gives you 2 years. So that's 136.05 plus 349.92 to give you 485.97. And you can go here to the calculator or the Excel solution if you would like to. And there's a timeline showing the deposits and the calculations here. Okay. There's another, now we're going to work on present value. Remember, present value is what it's worth today, the present. We were offered an investment that will pay $200 in 1 year, $400 the next year, $600 the following year, and $800 at the end of the fourth year. You can earn 12% on similar investments. What is the most you should pay for this one? Well, if we can earn 12% on similar investments, we wouldn't want to earn any less on this investment that I've been offered. Okay, so let's go and do the calculations. In this case, we're working backwards, okay? So the cash flow is equal to the amount that we're going to receive in a year, okay? And if we're going to take the 200 divided by 1.12 to the first power equals 178.57. All right, now, again, that reasonableness check. If you're going to receive $200 in a year, today it should be worth less because what we can deposit that $178.57, earn 12% interest on it for a year, and that would give us the $200. So in present value, the amount you calculate should be less than the amount that you will be receiving in the future. Okay, year 2, you're going to receive $400. So we're going to divide that by 1.12 squared. That gives you $318.88. In year 3, you're going to take $600 divided by 1.12 cubed, and that's going to give you $427.07. And year 4, you're going to take the 800 divided by 1.12 to the fourth power, gives you 508.61. And that gives you a total present value of $1,004.32.93. So that's the most you would pay for the investment. Anything more than that, you're not earning that 12% interest. Anything less than that is a good deal because you're earning more than the 12% interest. Okay, and here's a timeline showing everything. All right, here's uneven cash flows. If we have multiple uneven cash flows, how do we use the calculator? You're going to clear all. You're going to press CF, then the second key. So what that does is it takes you to some of the keys have 2 values to them, and it takes us to that second value. And then, whoops, what happened here? We're going to hit CE/C, and then CF is displayed as a 0. We're going to enter the period 0 cash flows. If it's an outflow, you're going to press the plus or minus sign to change the sign to minus. If it's an inflow, you keep it as a plus. And then to enter the figure in the cash flow register, press enter. Then you're going to move down to the next cash flow register, enter the cash flow amount, press enter, enter the down arrow to move to the next one. The default counter value is 1. And to accept the value of 1, press the down arrow again. To change the counter, enter the correct count and press enter and then the down arrow. Then you're going to repeat for all the cash flows and orders. All right, to find the actual net present value, you're going to press NPV. 1 appears on the screen. I appears on the screen, not 1. You're going to enter the interest rate, press enter, and then the down arrow to display the net present value. Then you're going to press compute, and that'll give you your net present value. Okay, so in this case, we have the 0 at the beginning, 200 at the end of year 1, 400 at the end of year 2, 600 at the end of year 3, 800 at the end of year 4. This is how we would do it in the calculator. You're going to hit CF for cash flows. You're going to hit second, and then go to CE/C and click on that. Then it's going to come. It should come up and give you the C00. That's the cash flow in year 1. You're going to enter 0, hit 0, and hit enter. It's going to then pop up and give you CO1, and you're going to hit 200 and enter. and then it's going to give you the FO1, and you're going to hit 1 and enter. You're going to CO2 400, FO2 1, CO3 600, FO3 1, CO4 800, FO4 1. Then you're going to hit net present value. It's going to come back and ask you for the interest rate. So you're going to enter 12. You're going to hit the down arrow, and you're going to hit net present value, compute, and then it should give you the 143293. I think it's easier to understand when you actually have an example on how to do it. Okay, you're considering an investment that will pay you $1,000 in 1 year, $2,000 in 2 years, and $3,000 in 3 years. If you want to earn 10% on your money, how much would you be willing to pay? Okay, so this is the formula solution. The present value is equal to $1,000 divided by 1.1 to the first power. End of the first year, first power. That gives you $909.09. Again, that reasonableness check. Am I using the right formula? This value should be less than what I'm going to get at the end of 1 year, because this value is going to earn interest to get me up to that $1,000 at the end of the first year. $2,000 divided by 1.1 squared gives me 1,65289. $3,000 divided by 1.1 to the third power gives me 2,253.94. Add those all together, it gives me 4,815.92. Okay, your broker calls and tells you that he has this great investment opportunity. You invest $100 today, and you will receive $40 in 1 year and $75 in 2 years. You require a 15% return on investments of this risk should you take the investment. And what we would expect is, if the value we come up with is less than 100, when we do our analysis, we wouldn't take the investment. If the value is $100 or more, we would take the investment. Okay, so using the calculator, we're going to hit CF for cash flow, second, and CE/C. It'll come and give you the CFO. You're going to enter 0 and enter. CF1, you're going to hit 40 and enter. FF1, you're going to hit 1 and enter. CO2, you're going to enter 75 and enter. FO2, you're going to hit 1 and enter. Then you're going to hit NPV for the net present value. It's going to ask you the interest rate. So it's going to give you the and you're going to hit 15 and enter. You're going to hit the down arrow and the CPT button to compute. And the value turns out to be $91.49. So the value of this investment, the present value, what it's worth today, is $91.40. We're going to invest $100. So we'll actually lose almost $8.50, $8.51. We'll lose if we make this investment. So it's not a good investment. Okay, next is an example for retirement savings. You are offered the opportunity to put some money away for retirement. You will receive 5 annual payments of $25,000 each, beginning in 40 years. Okay, the question is, how much would you be willing to invest today if you desire an interest rate of 12%? Okay, so the key word here to tell you whether you're using present value or future value is how much are you willing to invest today, the present. So you're going to be using present value factors. Okay, so we're going to take the CF key, second, CE/C, then we're going to put in the calculator, the CF, the cash flow in year 0 is 0. The CO1 is 0. Um, FO1 is 39. That's the number of periods. Then the CO2 is going to be after 39 periods. We're going to get 25,000, hit enter. And then the FO2, we're going to hit 5 because that cash flow is going to happen 5 times. Enter. Otherwise, you could go in and hit CO3 25, enter, FO, you could go through it each time. Instead, you can type in 5, enter, because that'll tell us for the next 5 years from year 40 to year 44, I guess that would be right, you're going to get $25,000. Okay, so we want to find the net present values, hit the NPV. It's going to ask for the interest rate. We're going to hit 12 and enter. We're going to hit the down arrow, and then we're going to hit the CPT, the compute button. That investment is worth $1,084.41. Huge. Think about this. We invest $1,084.71 today. If we can get 12% interest for 40 years, we could get $25,000 at the end of each year. And if you look at that without taking any kind of present values or adjustments, that's, 5 times 25 is $125,000 in the future. The big thing is you probably couldn't get 12% interest. Interest rates are way low today. Okay, and this is the timeline for that one. You get 0 from 0 to year 39. In year 40, 41, 42, 43, and 44, we're going to get 25,000. Okay, the quick quiz, I'm going to let you take that on your own. If you have questions on it, please contact me. And the next couple slides are going through the quiz. I strongly encourage you to take the quiz and then check your answers rather than looking at the answers. I think you get a lot more out of it if you at least try to do it yourself. Oh dear. Okay, hang on a second. I'll get us there. Okay. Now we're going to talk about something called annuities and perpetuities. An annuity is a finite series, okay? Finite meaning it's going to end at some point, of equal payments that occur at regular intervals. And regular intervals is important. You can't have a payment 1 year and then another 3 years and then 2 years and then 5 years. They have to be regular intervals, once a year, once a quarter, once a month, something like that. If the payment occurs at the end of the period, it's called an ordinary annuity. And most examples we're going to look at are an ordinary annuity. But if the payment occurs at the beginning of the period, it's called an annuity due. And we have to handle those differently because if the payment occurs at the beginning of the period, then there's interest involved for that first year. If it occurs at the end of the period, it won't have interest that first year. So it's very important to know which one you're working with. Perpetuity is an infinite series of equal payments that will go on forever. Example of that, I just, on my Facebook feed, I saw Publishers Clearinghouse, and, they said that you would get $5,000 for forever, basically. So that would be a perpetuity. Okay, there's 2 formulas you use. For perpetuity, you take the payment divided by R, which is the interest rate. And for annuities, you're going to take the payment for present value of annuities. You're going to take the payment and you're going to take 1 minus 1 divided by 1 plus R to the T, which is the time period, divided by R again, which is the interest rate. In the future value, you're going to take the payment, going to multiply that by 1 plus R to the T minus 1 divided by R. Okay, so let's do an annuity. The payment key on the calculator is used for the equal payment. The sign convention still holds. So if we're making payments, it would be a negative. If they're coming in, it would be a positive. To switch between an ordinary and annuity due, what you're going to do is you're going to see it should normally be set for an ordinary annuity. If you see BGN or begin in the display of your calculator, basically that means it's set for an annuity due. Okay, using the TABA2 plus, you're going to set the annuity time parameters first. First thing you have to do is set it as either ordinary annuity or annuity due. So you would set N for an ordinary annuity, what? Or BGN for an annuity due. How do you do that? You press second, and you're going to press BGN above the payment. And it's a toggle switch. So if you press it once, it'll give you BGN. If you press it the second time, it'll disappear. And then it's an ordinary annuity. And, you can just go back and forth between the two. Okay, Excel functions we're going to use for this. We're going to use future value. And how we adjust for an ordinary annuity or annuity due is the last value where it says type. We're going to use 0 if it's an ordinary annuity. And you really don't have to enter anything there. It automatically assumes it's 0. If it's a new annuity due, you need to enter 1. So in all cases, like in the calculator, if you're going to have a annuity due, you need to do something. In the Excel spreadsheets, if it's an annuity due, again, you need to do something. If it's an ordinary annuity, you can kind of ignore it. Okay, important points to remember. The interest rate and the time period must match. Okay, what does that mean? Well, annual periods are, you would use an annual rate. Most of the time, an interest rate is quoted as an annual rate. If it's not an annual rate, they will tell you what it is. So they might say 1% per month. But if they say just say 12%, you assume that's for a whole year. So if the time period, if you're getting payments on the annuity monthly, you have to have a monthly interest rate. So if the annual rate is 12%, the monthly rate would be 12% divided by 12, or 1% per month, and that's what we would use. You have to make sure that the interest rate and the time period match up. Okay, or otherwise you're mixing apples and oranges. Okay, the sign convention, again, very important to use the correct sign here. Cash inflows are positive, cash outflows are negative. Okay, let's go in and do a example. All right, in this particular one, we're gonna look at the same values, but in one case, we're going to show it as a cash inflow, and the other case, we're going to show it as a cash outflow. Okay, so implies that the first one implies that you deposited $100 today and plan to withdraw $20 a year for 5 years. So N is 5, the interest rate is 10%. The present value is minus 100, which means we put $100 in this and deposited in this, or we're going to, the present value is minus 100. So we invested $100 and $20 is the payment. So we're going to get that $20 a year for 5 years. So the future value is $38.95. Okay. In this example, it implies you deposited $100 today and plan to add $20 a year for 5 years. Okay, so we're going to go back, and the N is 5, interest rate is 10, the present value, what we added today or deposited today was minus 100. The payment, since we're going to be adding more, cash flow is going out to this investment, it's going to be a minus 20, and the cash flow, we're going to compute, see the future value, and it's 283.15. Okay, just to give you again that sense of, is this reasonable? You take this one and you're going to end up getting $20 a year for 5 years. And they want you to compute the future value of that. In this one, they were adding, so let me backtrack here. In this one, we're getting payments, cash flow is coming in, which means this $100 in investment, we're taking back what we invested. In this one, we're putting more in, so the total value here should be greater than what our investment is. We're investing $20 a year for 5 years, so that's $100 plus 100, and future value is 283.15. So we're putting in 200. With interest, we now have 283.15. Okay, here's an annuity example. We're going to go through each of the 3 methods here. You can, let's see here. You can afford to spend $632 per month. The going rate is 1% per month for 48 months. How much can you borrow? You borrow money today, so you need to compute the present value. Okay, we're borrowing today. Always ask yourself, am I trying to figure out what I need today or what something is going to be in the future? In this case, we need to find out how much we can borrow if we can only afford $632 a month. Okay, so using the calculator, we're going to put 48 equals N. The interest rate's going to be 1% per month because they quoted it as per month. So we don't have, this is a per month payment. This is an interest rate per month. So we don't have to adjust the interest rates. It's given to us in the same form that the payment is going to be made in. The payment, 632 payment, the future value is 0. Compute the present value, that's $23,999.54 or $24,000 if we round it. So let's say we're using this to buy a car. We could buy a $24,000 car if we're willing to make $632 a month car payments. Expensive. Using the formula approach, we would put in the payment, the 632 in the payment, 1 minus 1 times R 1.01, because that's the interest rate, to the 48th power, that's for 48 months, divided by the R, which is 0.01. That's going to give you, if you go through all the math, that'll give you 24,000. And then using Excel, you would use the present value function, 0.01, 48 minus 6, this is interest rate, number of periods, the payment, and it's going to come back and give you the present value of about 24,000. Okay, here's a look at another annuity example, sweepstakes. Suppose you win the Publishers Clearinghouse $10 million sweepstake. The money is paid in equal installments of $33,333.33 over 30 years. If the appropriate discount rate is 5%, how much is the sweepstakes actually worth today? Okay, it would be the 333 times 1 minus 1 divided by 105 to the 30th power divided by 0.05. Okay, so it's 1 minus 1 divided by R to the T, the time, which is 30 years, divided by 0.05. And we don't have to adjust because they didn't say this was any period, so you assume it's a year. So this is 30 years, this is 5% per year, okay? And if we calculate that out, that's 5,124,150.29. So the present value of what you won was really considerably less than the future value. Okay, buying a house. Here's another example. You're ready to buy a house and you have $20,000 for down payment and closing costs. Closing costs are estimated to be 4% of the loan value. You have an annual salary of $36,000. The bank is willing to allow your monthly mortgage payment to equal 28% of your monthly income. The interest rate on the loan is 6% per year with monthly compounding. In other words, because you're going to be making monthly payments, it's going to be the 6% divided by 12 or 0.5% per month for a 30-year fixed rate loan. How much will the bank loan you? How much can you afford for the house? So there's two questions we need to ask. How much will the bank loan you? How much can you afford for the house? Okay, so the first one, the bank loan. Monthly income is $36,000 divided by 12 is $3,000 a month. The bank will loan us an amount that would equal 28% of that payment. So 0.28 times, that income, I'm sorry, 0.28 times 3,000 is $840. So the most the bank will loan us is $840. So if I want to find the present value of that, I'm going to take 0.05 for the interest, 0.005, I'm sorry, for the interest rate, because it's 0.5%, 360, because it's 30 years and there's going to be 12 payments per year, that's 360 is your N. The minus 840 is the payment, and it's minus because the payment's going out, and 0 for the last item. We're going to compute, because I think that's future value. Compute present value is equal to 140,105. Okay, so that's the amount of the loan. That's not how much you pay for the house. Okay, so that the loan's 140,105. So now we have to figure out how much of the down payment is going toward the house. There's closing costs of 4% of the loan. So I'm going to take 4% times the loan value of 140,105. My closing costs are 5,604. So out of the 20,000 in the down payment, 5,604 is closing costs. Okay, so that isn't going to go, that's just money that it cost us to go through and get the loan. So that doesn't impact the value of the house at all. So the amount we put down on the house is $14,396. So the total amount that we paid for the house is the 140,105 loan plus our down payment that is applied to the loan of $14,396. So the total we paid for the house was $154,501. Okay. Quick loan quiz on part 2. I'll let you take that one. Finding the payment. Okay, now we're going to do some, we're going to find payments. We're going to find the number of payments. I'm going to show you how to look for different things other than the present value and the future value. Okay, suppose you want to borrow $20,000 for a new car. You can borrow at 8% per year, compounded monthly. Okay, so we're going to have to take it at the 8% is a yearly. So we're going to have to take that 8% divided by 12 to get our interest rate per month of 0.66667. If you take a 4-year loan, what is your monthly payment? So we're going to put a 4-year loan, 4 times 12 months out of a year is 48. So that's your N. Your interest rate per month is 0.66667. The present value is $20,000, what you're paying for the car today. If I compute the payment, that's $488.26. Okay, so you would have to make payments of $488.26. Okay, the payment in Excel, you would use the payment function, the PMT, because we're solving for the payment. And the payment function first looks at the interest rate, then the number of periods, then the present value, and that's going to be equal to it should equal 488.26. Okay, just go back here. They're showing us the two different ways. They don't show us the formula way here. I mean, if you want to try and do the formula way, go to it. I just think it's very difficult math-wise, and I think that's why they don't show it here. You're much better off using the financial calculator. I know it's an investment in getting the financial calculator, but on an exam, you're going to get the answers much faster that way. All right. If you decide you're going to use Excel, what I would recommend is set up an Excel spreadsheet that does that already has everything set up for the computations, and you just have to plug in numbers and it'll give you the answer. Okay, number of payments. You have $1,000 due on a credit card. The payment is $20 per month minimum. The interest rate is 1.5% per month, or 18% per year. If you take 1.5 times 12, that's 18%. Very high. All right. And important, the sign convention matters. It makes a huge difference. I was doing a problem, one of the homework problems that is an issue, and I forgot to put the right sign convention in. I couldn't come up with the answer. Then I realized I forgot the minus sign and came up with the right answer. So it's really important to make sure you think about that. Interest rate is 1.5. The present value is 1,000. The payment's minus 20 because the payment is going out, so it's minus 20. The future value is 0. We're going to CPT, and then it's going to come back and give you N is equal to 93.111 months, or 7.75 years. Okay, so I mean, if you take that 93, just to show you, by taking the 93.111 per month, I'm multiplying that by the $20 payment, and the total that we would be paying based on those 93.111 month is $1,862.22. So it's going to take us 7 years to pay off at the minimum payment, and we borrowed $1,000, and we're going to end up paying back $1,862. Don't want to do that if you can get around it. Okay, in Excel, you're going to use the end period function to find the number of periods. The first one is the interest rate. The second one is the payment. The third one is the amount, the present value. The fourth one's the future value, so that's going to be 0 because we're not working with the future value here. And that should give you the 93.111 months. Okay, finding the number of payments, another example. Suppose you borrowed $2,000 at 5%, and you're going to make annual payments of $734.42. How long before you pay off the loan? Okay, so we're going to put in the interest rate is 5%. Present value is $2,000. And we're leaving it at 5% because they're annual payments. This doesn't say anything, so it's an annual interest rate. We're making annual payments, so both are the same. Minus $734.42 is your payment. It's a negative because the cash is going out to make that payment. Future value is 0. We're going to do CPT compute N, and it should come up to 3 years. In Excel, we're going to do the number of periods. Interest rate is 0.05. Payment is minus 734.42. Present value is 2,000. Future value is 0. And that should again also give you 3 years. Okay, so we found the payment, we found the number of periods, now we're going to find the rate. Suppose you borrow $10,000 from your parents to buy a car. You agree to pay $270.58 per month for 60 months. What is the monthly interest rate? All right, so the number of periods in the calculator, N is 60, 10,000 is the present value. The payment is $207.58, so that's minus $207.58 for the payment. The future value is 0. We compute the interest rate, so we're going to compute I slant Y. Interest rate is 0.75% per month. So if we want that as an annual rate, we would take that 0.75 times 12, and that turns out to be 9% per year. In Excel, you'd use the rate function. 60 payments is N, minus 207.58 is the payment, 10,000 is the present value, that's what I'm borrowing today to buy the car, and the future value is 0. Okay, if you want to receive $500 per month for the next 5 years, how much would you need to deposit? Oh, this is the quiz. I'm going to let you take the quiz on your own. I thought that didn't look familiar to me. Okay, future values for annuities. Suppose you begin saving for retirement by depositing $2,000 per year in an IRA. If the interest rate is 7.5%, how much will you have in 40 years? Okay, so in the calculator, N is 40, I slant Y, or interest rate is 7.5, the present value is 0 because we don't have anything in the retirement account initially. The payment is minus 2,000. We're going to compute the future value, and that turns out to be 454,513.05. Okay, using Excel, we're going to take the future value calculation. It's going to be 0.075 is the interest, 40 is the number of payments, 2,000 minus 2,000, is the payment, and 0 is the future value, yeah. Okay, and that again should give you the 454,513.04. And then this particular example, the future value is equal to the payment which is 2,000 times 1.075, which is the 0.075 is the interest rate, to the 40th power minus 1 divided by 0.075 is equal to 454,513.04. Okay, annuity due. In this one, you're saving for a new house and you put $10,000 per year in an account paying 8%. The first payment is made today. Okay, remember we said at annuity due, the payment is made at the beginning of the period, so that makes it an annuity due. How much will you have at the end of 3 years? Okay, so the first thing we have to do is we have to set it so that it will calculate an annuity due. So we're going to hit the second button, hit the BGN button, hit the second button again, and hit set. And that'll set it to an annuity due. Now, you go through those same steps when you're done with this calculation. You can see here, so it sets it back to an ordinary annuity. N is equal to 3, so how much we'll have in 3 years. 8 is equal to the I slant Y, the interest rate. The present value is 0. The payment is minus 10,000 because we're saving, so it's going out. We're going to compute the future value, and in the future, that $10,000 per year for 3 years will equal $35,061.12. Again, think about the reasonableness of your answer. $10,000 per year for 3 years without any interest would be $30,000. I would expect this number to be higher than $30,000 because we're earning interest on that investment, and it is. So it's at least from a reasonableness check, it sounds correct. Using Excel, we would use the future value function, and that's equal to 0.08. Interest rate, 3 is the N, minus 10,000 is the payments, 0 is the future value, and in this one we have to use the type key, and we've got to make that 1 because it is the annuity due. It's assumed to be 0 unless you put the 1 in there. 1 indicates an annuity due. All right, and in this case, the next one, we're going to calculate it for an annuity due, and it's going to be the $10,000 times 1.08 to the third power minus 1 divided by 1.08 times 1.08 equals the 35,000 rather, 06112. This next slide is a nice slide to have. It shows you some of the formulas and things. It's a good slide to keep available for the exam. If you want to, there's online calculators, and you can go online and find those. I would recommend, if you're going to use those, that you become comfortable with them before the exam, so you're not trying to learn how to use them while you're taking the exam, because it's not going to work. All right, here's a perpetuity example. The present value over perpetuity is the payment divided by the interest rate. So the required return, it's 40 payments, and required return is 2.5% per quarter. So 40 equals 1 divided by R. So if we calculate that out, R is equal to the 2.5%. If we were giving a dividend for new preferred stock, we would take 100 is equal to the payment divided by 0.25, and that should give us $2.50 per quarter. And here is quiz 4. Again, that's for you to take. And okay, so now we're going to talk about interest rates. The effective annual rate of interest is expressed as if it was compounded once per year. We would use this to compare two alternative investments with different compounding periods. The annual percentage rate is the nominal rate. It's the rate quoted by law. It's simply the periodic rate times the number of periods per year. You must always make sure, as we've been doing all along, that the annual periods equal the annual rate, and that if we're using monthly periods, we use a monthly rate. If you have an APR based on monthly compounding, you have to use monthly periods for lump sums or adjust the interest rate accordingly. All right, and these are just two slides that I think we just went through. The EAR formula for the effective rate of interest, effective annual rate, you're going to take 1 plus the APR divided by M to the M power minus 1. And using the financial calculator, you're going to hit the second key and you're going to hit ICONV. You're going to hit the second key and you're going to hit CV/C to clear the memory. There's 3 fields in the worksheet: the nominal rate, the effective annual rate, and the C/Y, the compounding periods. To compute the effective, you're going to enter the nominal and the compounding periods, and you're going to move to the effective and press compute. To compute the nominal, you're going to do the effective and the compounding periods, move to NOM and press compute. In Excel, you're going to Excel this one, unless you've installed the Analysis Tool Pack, which is an add-in, you will not be able to do these. It doesn't cost you anything to add the tool pack in, but you can do that. And if you do, you can use the effective rate and nominal functions to calculate the EAR and the APR. Okay, which savings account should you choose out of these decisions? 5.5 with daily compounding or 5.3 with semi-annual compounding. Okay, so the first account, we're going to calculate what we want to do is on both of these, we want to calculate the effective rate. Okay, so the first one, the EAR, we can do it with the formula 1 plus the interest rate of 0.0525 divided by 365 days, because that's the daily compounding period, to the 365th power minus 1 should give you 5.39. Okay, that's using the formula. With your calculator, you can take ICONV equal the nominal rate, which is 5.25, the C minus Y is 3.65, and then you're going to go to Effect and hit EFF and hit Compute, and it gives you 5.3899. In Excel, you would use the Effect function, and you would put in the daily compounding rate and the number of days, and it should give you that same 5.39. For the second one, you would go through the same idea, only now instead of 5.25, we're going to use 5.3. So it's the same thing as what we did up here. We're just going to change that interest rate. And when we change the interest rate, we have to change the number of periods because this one is a semi-annual compounding. So that's 2 periods per year. So it's 1 plus 0.053 divided by 2 to the second power minus 1 is 5.37. And then we're going to type in the I for the, so that's using the formula. Using the calculator, it's ICONV, NOM equal 5.3. The compounding periods is 2, so that should give you effective rate is 5.3702. And Excel, we would use Effect and get 5.37. Okay, computing APRs. What is the APR if the monthly rate is 0.5%? We just multiply it by 12, and that gives us 6%. If the APR is a semi-annual rate of 5%, what would be the annual rate? We'd multiply it by 2, because that's semi-annual, that's 2 periods per year, and that gives us 1%. Okay, what is the monthly rate if the APR is 12% with monthly compounding? Okay, so we're going to say 12% divided by 12 equals 1%. Then it says, can you divide the above APR by 2 to get the semi-annual rate? No, we actually need the APR based on semi-annual compounding. Okay, so let's go through and do a couple more examples here. Suppose you can earn 1% per month on $1 invested today. What is the APR? We're going to take 1 times 12, or the annual rate is 12%. How much are you effectively earning? So what is the EAR? The EAR would be equal to 1 times 102 to the 12th power. That gives you the future value of 1.06. The rate is going to be that gives you 1.1268 minus 1 divided by 1 gives you an interest rate of 12.68%. That's using the formula. Using the calculator, you're going to type in INCONV. The nominal rate is 12. The compounding periods are 12. And the effective rate we're going to compute, and that's 12.6825. And in Excel, we would use the effect function. Okay. Suppose you put it in another account and you earn 3% per quarter. What is the APR? 3% per quarter times 4 quarters per year is 12%. How much you are effectively earning? This one uses the formula approach. This one uses and came up with 12.55. This one uses the financial calculator using the ICONV function, and that gives you the 12.5509. And the last one, the effect is equal to 0.12 and 4. Okay. Right. Okay, we're going to talk a little bit about computing APRs from EARs. Okay, so in other words, if you've been given the effective annual rate, you can calculate the APR using this formula: M times 1 plus the EAR divided by M minus 1, where M is the number of compounding periods. So for this example, suppose you want to earn an effective rate of 12% and are looking at an account that compounds on a monthly basis. What APR must they pay? So it's 12% is the rate. I'm sorry, 12 compounding periods. 1 plus the 12% for the rate divided by 12, because that's the number of compounding periods, minus 1. And when you do the math, it turns out to be 11.39%. If you use your calculator, you're going to use the ICONV function. The effective rate is 12, the compounding periods per year is 12, and that should give you the 11.3866. And in Excel, you would use the nominal function. And again, you would need that Excel add-in to do that. And that would give you 0.12 for the rate and 12 for the compounding periods. Okay. Computing payments with APRs. Suppose you want to buy a new computer. The store is willing to allow you to make monthly payments. It costs $3,500. The loan period is for 2 years. The interest rate is 16.9% with monthly compounding. What is your monthly payment? Okay, so first of all, it's over 2 years, and if you're going to make a monthly payment, it's 2 times 12, because you're going to make a total of 24 payments. So that's going to be your N. That's a monthly payment. The 16.9% is an annual rate with monthly compounding. Okay, so we need to divide that by 12. So that's 16.9 divided by 12 is 1.4033. That gives you your interest. That's your interest rate per month. The present value is $3,500. The future value is 0 because we won't have anything in the future. We won't owe anything. And we're going to hit compute payment and should be $172.88. If we use Excel, we're going to use the payment function. The first thing is the interest rate, number of periods, present value, and future value, and that should give you the $172.88. Okay, suppose you deposit $50 a month into an account that has 9% APR based on monthly compounding, how much will you have in 35 years? Okay, so our N is going to be 35 years times 12 because we're making the payments monthly. So that's 420 N. The interest rate of 9% is an annual rate. So we're going to take 9 divided by 12, and that's 0.75. The present value is 0 because we haven't deposited anything yet. And the future, we're going to compute the future value, and that's 147,089.22. Okay. The future value is going to, the first thing you'll have is the interest rate. It's 0.75. So you have to add 2 zeros in front of that. It's 0.0075. 420 is the number of periods. 50 is the payment minus 50 because it's going out and going into an investment. And 0 is your present value. If you put all those in Excel, that should give you the 147,089.22. Let's see, you need $15,000 in 3 years for a new car. If you can deposit money into an account that pays an APR of 5.5% based on daily compounding, how much would you need to deposit? So we're going to take the, first of all, we have to calculate the number of periods. We have 3 years, and it's daily compounding, so we're going to multiply it by 365, so that turns out to be 1,095 days. The interest rate is 5.5%. APR, annual percentage rate, is 5.5%. If it's compounding daily, we have to divide that by 365, and that gives us 0.0158 of 1.015068493. In a case like that, if you just rounded that to 0.015, actually it should be 0.00, no, that's right, 0.015 here, I would be fine with that. You don't have to go to that many decimal places. The payment is 0, and the future value has to be 15,000. The future value is 15,000. That's what we need in that account. What we're solving for is what we have to deposit today. So that's going to be the present value. So we're going to compute the present value, and that's 12,718.56 if we can make 5.5% interest. Okay, and this is the quiz on that part of the chapter. Pure discount loans. Treasury bills are an example of pure discount loans. In this case, what happens is the principal is repaid at some future date, and there's no periodic interest payments. If a T-bill promises to pay $10,000 in 12 months and the market rate is 7%, how much would the T-bills sell for in the market? Okay, so the period is 1. The future value, we're going to get $10,000 in 12 months, so that's the future value. The interest rate is 7. We're going to compute the present value, and that's going to give us minus 9345.79. Okay, and the present value for Excel, we'd use the present value function. 0.07 is the interest rate, 1 is the period, 0 is the future or present value, 10,000 is the future value. Okay, an amortized loan with fixed payment example. Each payment covers the interest expense and reduces principal. Consider a 4-year loan with annual payments. The interest rate is 8% and the principal amount is $5,000. What is the annual payment? So we're going to use, we can calculate it manually if you want to. The principal amount is $5,000, so we're going to take the payment 1 minus 1 over the interest rate, and then to the number of periods. It's a 4-year loan, so 1.08 to the 4-year loans divided by the rate, which is 0.08, gives you a payment of $1,509.60. If we can use Excel, we're going to use the payment function. Interest rate is 0.08, N is 4, principal amount is $5,000, so that is going to be the principal amount is $5,000, so that's going to be the present value. 0 is the future value, and that gives you $1,509.60. And using the calculator, you would plug in those values to get $1,509.60. Now, one thing you should know about interest payments, all right, in this particular example, every month they're making, or every year they're making a payment of $1,509.60. But what happens is interest is, part of that is interest and part of it is principal. And how we calculate the interest is we look at the new ending balance that is owed and calculate the interest based on that. So for the first period, we owe $5,000. So the interest rate is 8%. 8% times 5,000 is $400. So out of this total payment, $400 is interest, of $1,109.60 is principal, or what we borrowed. It's reducing how much we borrowed. So we're going to take that 5,000, subtract what we paid back, and get a new ending balance. That new ending balance now becomes what we charge interest on. Okay, so we're going to take 3,890.40 times 8%. That gives you $311.23. If we're making a total payment of $1,509.60, interest is $311.23. That gives you $1198.37 going toward the principal. And our new balance, which is the $38.40 minus this $1198.37, is now $2,692.03. Okay, so that's going to be the new balance. We're going to take 8% of that. That's $215.36. The total payment's $1,509. The interest portion of that payment is $215.36. The principal is the difference, $1,509.60 minus $215.36 gives you principal paid of $1,294.24. I take that from the beginning balance, subtract that principal paid. My new principal balance is $1,397.79. And in the last year, we're going to take that, multiply it by 0.8. That's going to give us the $111.82. Subtract that from the total payment to give us the principal paid of $1,397.79. And our ending balance is 0. We've paid off the loan. Okay. So, what I want you to notice is the interest goes down as the number of years go by because you're paying more and more of the principal each time, and the interest is being charged on a smaller and smaller balance. That's the way, a car loan would be. House, the mortgage on your house, in the beginning you're paying almost nothing on the principal. By the end you're paying almost all principal. So that would be how all of those would be done. Okay, now that's the last of chapter. The rest of it are examples you can go back to and look at that go along with, when there was a slide that we did at the Formula Way and using Excel or the calculator. That's what's in those last slides. So